Welcome to the lesson on trigonometric ratios of specific angles. At the end of this lesson, you will be able to state the trigonometric ratios of angles of measure 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. You will also be able to state trigonometric ratios of complementary angles. Consider angle C in the right-angled triangle ABC. You already know that angle C has some trigonometric ratios associated with it. We are now going to see some special situations with respect to the values of the angle C. Now, let us see what happens if we decrease angle C till it approaches 0. Observe carefully. As angle C decreases, the length of AB decreases. At the same time, point A approaches point B, so that length AC approaches length BC. When angle C becomes 0, we can say that the length of AB, the side opposite to angle C, also becomes 0. Also, the length of hypotenuse AC becomes equal to the length of BC, the side adjacent to angle C. Let us calculate the trigonometric ratios of angle C in this position. We know that sin C is equal to the ratio between AB, the side opposite to angle C, and AC, the hypotenuse. We have seen that AB becomes 0 when angle C is equal to 0 degrees. 0 divided by any quantity is 0. Thus, we can say that sin 0 is equal to 0. We know that cos C is equal to the ratio between BC, the side adjacent to angle C, and AC, the hypotenuse. We have seen that AC becomes equal to BC when angle C is equal to 0 degrees. Thus we can say that cos 0 is equal to 1. We know that tan theta is equal to sin theta divided by cos theta. Substituting theta equal to 0 degrees and simplifying, we get tan 0 degrees is 0. Let us look at other trigonometric ratios of 0 degrees. Cosec 0 is equal to reciprocal of sin 0, which is 0. Since any quantity divided by 0 is undefined, cosec 0 is undefined. Sec 0 is equal to reciprocal of cos 0. Thus, sec 0 is equal to 1. Cot 0 is equal to reciprocal of tan 0. Therefore, cot 0 is undefined. Let us quickly recap the trigonometric ratios of an angle that measures 0 degrees. consider angle C in the right-angled triangle ABC. Now, let us see what happens if we move angle C till it approaches angle B, which is equal to 90 degrees. Observe carefully. As angle C increases, the length of BC decreases. At the same time, point C approaches point B, so that the length AC approaches the length AB. When angle C becomes 90 degrees, we can say that the length of BC, the side adjacent to angle C, also becomes 0. Also, the length of the hypotenuse AC becomes equal to the length of AB, the side opposite to angle C. Let us calculate the trigonometric ratios of angle C in this position. We know that sin C is equal to the ratio between AB, the side opposite to angle C, and AC, the hypotenuse. We have seen that AC becomes equal to AB when angle C is equal to 90 degrees. Thus, we can say that sin 90 is equal to 1. We know cos C is equal to the ratio between BC, the side adjacent to angle C, and AC, the hypotenuse. We have seen that BC becomes 0 when angle C is equal to 90 degrees. 0 divided by any quantity is 0. Thus we can say that cos 90 is equal to 0. We know that tan theta is equal to sin theta divided by cos theta. Substituting theta equal to 90 degrees and simplifying, we get tan 90 degrees is undefined. Let us move on to other trigonometric ratios of 90 degrees. Cosec 90 is equal to reciprocal of sin 90, which is 1. Thus, cosec 90 is equal to 1. Sec 90 is equal to reciprocal of cos 90, which is 0. Thus, sec 90 is undefined. Cot 90 is equal to the ratio of cos 90 and sin 90. Hence, cot 90 becomes 0 upon 1, which is equal to 0. Thus, cot 90 is equal to 0. As tan 90 degrees is undefined, we do not consider the definition that cot of an angle is the reciprocal of tan of the angle. Let us quickly recap the trigonometric ratios of a 90-degree angle. Consider a right-angled triangle ABC, in which angle C is equal to 45 degrees. Now, this has some interesting effects on triangle ABC. Given angle C equal to 45 degrees and angle B equal to 90 degrees, by angle sum property, we find that angle A is also equal to 45 degrees. Since sides opposite to equal angles in a triangle are equal, we can say that the length of AB is equal to the length of BC. Let this length be x. Applying Pythagoras' theorem in triangle ABC, we find the length of hypotenuse AC as root 2 times x. Now, we are all set to find trigonometric ratios of the 45-degree angle C. Sin 45 degrees is equal to the ratio of AB, the side opposite to the angle C, and the hypotenuse AC. Putting in the values of AB and AC, we get sin 45 degrees as 1 by root 2. Cos 45 degrees is equal to the ratio of BC, the side adjacent to the angle C, and the hypotenuse AC. Putting in the values of BC and AC, we get cos 45 degrees as 1 by root 2. Now, tan 45 degrees is equal to the ratio between sin 45 degrees and cos 45 degrees. Since sin 45 and cos 45 are both equal to 1 by root 2, tan 45 is equal to 1. Cosec 45 is equal to the reciprocal of sin 45 degrees. Thus, cosec 45 is equal to root 2. Sec 45 degrees is equal to the reciprocal of cos 45 degrees. Thus, sec 45 degrees is equal to root 2. Note that sin 45 degrees is equal to cos 45 degrees and cosec 45 degrees is equal to sec 45 degrees. Cot 45 degrees is equal to the reciprocal of tan 45 degrees. Since tan 45 degrees is equal to 1, cot 45 degrees is also equal to 1. Let us quickly recap the trigonometric ratios of 45-degree angle. Consider an equilateral triangle ABC. By definition, each angle of an equilateral triangle is equal to 60 degrees, and all its sides are equal. Let the length of each side of equilateral triangle ABC be x. Let us draw a perpendicular AD from vertex A to its opposite side BC. Again, by definition, a perpendicular drawn from a vertex to its opposite side in an equilateral triangle bisects the angle at the vertex and its opposite side. Thus, AD divides angle A into two equal parts. It also divides side BC into two equal parts, BD and CD, each equal to x by 2. Applying Pythagoras' theorem to triangle ADB, we get the length of side AD as root 3 by 2 times x. Now, let us find trigonometric ratios of angle B equal to 60 degrees in triangle ADB. Sin 60 degrees is equal to the ratio of AD, the side opposite to the angle B, and the hypotenuse AB. Putting in the values of AD and AB, we get sin 60 degrees as root 3 by 2. Cos 60 degrees is equal to the ratio of BD, the side adjacent to the angle B, and the hypotenuse AB. Putting in the values of BD and AB, we get cos 60 degrees as 1 by 2. Tan 60 degrees is equal to the ratio between sin 60 degrees and cos 60 degrees. Putting in the values of sin 60 degrees and cos 60 degrees, we get tan 60 degrees is equal to root 3. Cosec 60 degrees is equal to the reciprocal of sin 60 degrees. Thus, cosec 60 degrees is equal to 2 by root 3. Sec 60 degrees is equal to the reciprocal of cos 60 degrees. Thus, sec 60 degrees is equal to 2. Cot 60 degrees is equal to the reciprocal of tan 60 degrees. Since tan 60 degrees is equal to root 3, cot 60 degrees is equal to 1 by root 3. Let us quickly recap the trigonometric ratios of a 60-degree angle. Remember, when we drew AD perpendicular to BC, we not only divided BC into 2 equal parts, but we also divided angle BAC into 2 equal parts. Now, let us find trigonometric ratios of angle BAD equal to 30 degrees in triangle ADB. Sin 30 degrees is equal to the ratio of BD, the side opposite to the angle BAD, and the hypotenuse AB. Putting in the values of BD and AB, we get sin 30 degrees as 1 by 2. Cos 30 degrees is equal to the ratio of AD, the side adjacent to the angle BAD, and the hypotenuse AB. Putting in the values of BD and AB, we get cos 30 degrees as root 3 by 2. Tan 30 degrees is equal to the ratio between sin 30 degrees and cos 30 degrees. Putting in the values of sin 30 degrees and cos 30 degrees, we get tan 30 degrees is equal to 1 by root 3. Cosec 30 degrees is equal to the reciprocal of sin 30 degrees. Thus, cosec 30 degrees is equal to 2. Sec 30 degrees is equal to the reciprocal of cos 30 degrees. Thus, sec 30 degrees is equal to 2 by root 3. Cot 30 degrees is equal to the reciprocal of tan 30 degrees. Since tan 30 degrees is equal to 1 by root 3, cot 30 degrees is equal to root 3. Let us quickly recap the trigonometric ratios of a 30-degree angle. Consider the two acute angles, angle A and angle C, in a right-angled triangle, ABC. By the angle sum property of triangles, we know that the sum of angles A, B and C in the triangle ABC is 180 degrees. Angle B in the given triangle is a right angle. Putting in the value of angle B in the previous equation and simplifying, we see that the sum of angles A and C is equal to 90 degrees. Thus, we can say that angles A and C are complementary angles. What is true for triangle ABC is true for all right-angled triangles. The two angles, besides the right angle in a right-angled triangle are always acute angles and complementary angles. Now, we can also represent angle C as 90 degrees minus angle A. The table here shows the trigonometric ratios of angle A. The table here shows the trigonometric ratios of complementary angle of angle A, that is, angle C, or 90 degrees minus A. Now, let us compare the values of the trigonometric ratios of the two complementary angles. Comparing the two tables, we see that the value of sine 90 minus A, that is, AB upon AC, is also equal to cos A. Similarly, we see that the value of cos 90 minus A, that is BC upon AC, is also equal to sine A. Similarly, we can find relationships between the other trigonometric ratios of angle A and its complementary angle. The table here summarizes the relationships between trigonometric ratios of complementary angles.